Hello. Thank you. I want to thank my hosts here for inviting me to take part in this wonderful event. And I have the best job in the world. I work at a place called the CITRIS Invention Lab. CITRIS stands for Center for Information Technology Research in the Interest of Society at the University of California in Berkeley. It's a wonderful place, and I can tell you a little bit about CITRIS. It was formed 2001 by a group of researchers who weren't satisfied with how the technology that was developed in labs were brought to the market in useful products. There was a huge gap between research and development and usable products. So they started the Invention Lab, which is I describe it as a university makerspace, but it's so much more than that. Because what is a makerspace? It's a place that provides tools and knowledge for people to create physical objects. And the university setting is a little bit different. In my teaching, I've been teaching for about 15 years, and college level. And I've always worked with small kids in workshops and after-school programs. And the last couple of years, probably like 5 years or so, there's really been a decline in hand skills of incoming students at the university level. So at the Invention Lab, we try to teach everything from basic hand skills, how to use tools, what is a screwdriver, what is a pair of pliers, how do you use them safely, and then what can you make with those hand tools. We're a really well-equipped lab. We have probably about 10 different 3D printers, laser cutters, CNC routers, and high-end 3D printers, ProJet 3000, which is prints to a 20-micron resolution. U-prints, several commercial machines. We have a LPKF, which is a circuit board mill, and a other mill, which is also a circuit board mill. So a little bit more about the lab is we have all this equipment, and then we're open to all the students on campus. So you can be a student, staff, faculty, visiting a student or faculty, and you can have access to our lab. We also host roughly four classes out of the lab a semester, where the professor has their class in the lab. And then I'm usually involved in teaching half the class, the workshop, so it goes from a lecture to a hands-on demo all in the same room, which is really great because the students don't have to remember what they learned in the lecture. They can apply it right away at their work tables, which is really wonderful. I'm very lucky I get to work with amazing, brilliant people. This is Bjorn Hartman. He's a professor. I know he's too young to be a professor, isn't he? But brilliant, brilliant guy. And the classes held are undergraduate classes and graduate classes. And so the graduate students have a little bit more skill sets than undergraduates, but you're still teaching a lot of the basics. How do you make things? I say this is the best job in the world. I have the best career in the world. I'm a product designer. I studied industrial design at Art Center College of Design in Pasadena, California. Got out of my first job out of school. Actually, I started working before I graduated for electric vehicle technology company. This was way back in 1995. And so not very many electric vehicles back then. And it was we developed radar systems for cars, navigation systems for automobiles, climate controlled, heated and cooled seats. A lot of the technology you take for granted in vehicles today was developed at the company I worked for. Did museum design, exhibit design, medical medical products. What else? I did a lot of different things way back. Theater design. And then I got hired to do some toys by a toy company. And then that became a lot of fun. So I became a toy designer for a number of years and got to design tons of toys for kids. And they were always asking how I came up with these wonderful ideas for toys. And it's like, well, it's what I wanted as a kid. And what was great about an industrial design degree is it taught you how to prototype, how to make a rough model, how to write out your ideas, sketch or diagram, and communicate those ideas to others. And that's one of the core skills for a maker, is to be able to communicate their ideas, because it's very hard to make anything all by yourself. I rely on a lot of brilliant people to help me out when I'm designing something, and so do makers, any type of maker. So to be able to communicate your idea is really important, and we do that through sketching or a rough model. You can tape a couple of glue sticks together and a box to show your latest design and act out the functionality of that design. It doesn't have to be a pristine model to communicate your idea. Pristine model, the nice model comes later. So teaching students hand skills is very, very important. And then how to take those hand skills and develop these models, going from a low fidelity model, like I was talking about, just objects taped together to explain your idea, to a proof of concept model, which is a little bit more together, but it just has to function, do the basic task, and then to a refined model that maybe incorporates more of the size and shape and what you want it to do, and then to a final model, which is basically a looks like, works like model of your product or your idea. Here, these slides are in no certain order. I was going to cover a lot of different material. Safety is very important. I call that a face saver, and which I take wearing safety glasses for granted, or gloves, or a respirator, because I've been working with this all my life. But I forget that someone who hasn't used any hand tools has no idea of the dangers involved. Luckily, we go through extensive safety training, and for each student to have access to the lab, and usually it's just small reminders after that. So I spend most of my time teaching as opposed to policing safety in the lab. We also have, we do a community outreach. The last slide, we had some elementary school kids in there. We try to bring in lots of outside groups just to show them the state-of-the-art technology used in making today. Let's see. We are open, since anyone on campus can use the lab. We get a lot of different types of, a lot of different majors in. Usually traditional fabrication labs on campuses are mechanical engineering, electrical engineering, or computer sciences. They're the ones who have all the cool stuff. And we combine all those labs into one, but we open it to everyone. The woman on the left is a humanities major. She's a poet. And this is her poetry jar that I collaborated on. And when you pull out a little piece of paper, wrapped up origami piece of paper out of it, the jar recites a poem. She went around and had a curated group of poets recite their poetry, and she recorded them and captured it in this jar. So every time you pull out a little origami, you can unfold it, and you have a written word and the spoken word at the same time. And that's what, when she came in, she had never used a laser cutter, never used a CAD program, didn't know about different types of adhesives and stuff, and she made that all in a matter of about 14 weeks. And that's one of the greatest joys for me, is to get a student in with just an idea and very little skills, and teach them enough to they leave with their completed idea. And I wish I had all her stages of progress here, because that's one of the myths I want to dispel, is like you can go in and make a beautiful object on your first try. It takes at least 3 iterations to get anything near what you want it to do. because you learn along the way. You don't know exactly how it's going to perform. You think you know what you want. Isn't that true for everything? and then once you get it, you're like, oh, you see something totally different. Oh, and so you want to make changes to it. It doesn't stay static. What else? This was a great project. This was a one-week project for one of the classes. They have to do in 5 days. They have to have a computer input device and be able to type out the alphabet and numbers. And the next week, you have to play a game with it. Also, generate a game. And so you can see that people use found objects. Here's more of the younger crowd in here. Modifying equipment for research. This is a couple of the researchers. More kids in the lab. We have this, oops, going too fast. Back up. We have this small mill, it's called the Other Mill. It was developed by a San Francisco Bay company. And it's great. We'll do circuit boards, and we have a LP, it's called LPKF. It's about a $24,000 machine that actually the training for it takes about 2 hours. And it's great because it'll do amazing custom circuit boards, as small as you want. But this machine is about $3,000, under $3,000. And I usually open up the tutorial on the computer and tell the student to go through the tutorial and get to work. And they ask me to stay to help them. I'm like, no, you can do it. And pretty enough, usually in about an hour, they have their finished circuit board. So it's amazing that these new tools lower the entry bar to be able to use them. So students can go through and breadboard a circuit on a breadboard. They can design a circuit in a free online program and then cut it out, and they have a dedicated circuit board. We have lots of 3D printers scanning a piece of cabbage, I think, to 3D print. Oh, did I hit that twice? I did. Come on, okay, there we go. So at Berkeley, the students in CS and engineering, their male-female ratio is getting pretty even these days, which is great. And we try, it used to, a lot of the female students didn't have the experience with tools, and so they had a little bit steeper learning curve. These days, a lot of the male students don't have experience with hand tools, so it's at equal footing. And what's great about the female students is they listen and they remember the rules and the procedures. The guys just grab it and go until it doesn't work. Then they think about, well, what did I do wrong? So the female students are very fast learners. So we have like a computer input device there, putting together a large CNC router and more game controllers there. A lot of the projects are team projects. So in the classroom, we'll put a humanities major with an architect, with a CS, computer science, mechanical engineer, and electrical engineer, which is great because that's a very powerful team. And they get together and start building. And they do have to clean up after themselves. Every day, that table better have been clean when they were done. Otherwise, it gets incredibly messy. Teach them how to prototype. This was the first pass at it's actually a base and a stand for a couple of different circuit boards. And the student wrote notes on there to show all the changes that had to be made. And I told him that, there's going to be, he's like, well, I'll have it done in time. And I'm like, no, you need to do it right now because there's going to be lots of changes. And he didn't believe me. And then he cut it out and tried to fit everything. He's like, oh. And you can see my name on there. He's like, Mark, Chris, wanted something moved. So teaching them how to use these models as tools, not as pristine objects, and not as like, that didn't work, throw it away. Use it. We have, this was a furniture design class we were hosting in the lab. More game controllers. A lot of collaboration going on. And that's what's great about the Invention Lab, is since it's open to all majors, that most traditional labs on campus and shops, it's for mechanical engineering. So you go in and there's only mechanical engineers in there. You go in the computer science lab, it's only computer scientists in there. EE is only electrical engineering. Well, in our lab, you have all these people together. And if you don't know something, you can turn around and say, hey, who knows this? And you have an expert sitting right next to you. And so there's a lot of collaboration. And that makes every project turn out so much better because you have just such high collaboration. I call it cross-pollination. And it's not people asking questions. People, not just when they have problems, people wander through and then say, what is this you're working on? That's really cool. And then they explain what they're doing, and this person, he'll be a physicist, and he'll say, oh, well, have you thought about this? Try this. And so it's a lot of people are very curious about each other's projects, and it's a really great atmosphere. It's not like a traditional classroom. There's a laptop stand. It's a little cat laptop stand. She was very proud of that. And she had never used a CNC router. And what major is she? I forget her major, but this was all new to her. Sat down, did a file. It worked out on the first try on the CNC router, which is great. There it is. I want one of those. I kept the file so I could cut one out for myself later. A lot of 3D printing, a lot of sketching, a lot of diagramming. This is one of the classes, getting projects, deciding on projects. We give small assignments. The ring was a little assignment to learn how to use the 3D printer. And so they were 3D printing rings, laser cutters. There's our ShopBot, our CNC mill. And giving students who've never made anything before these powerful tools. Really, this student here, Anna, she's the one on this side here. She's a landscape architect, and she had an idea for a wall panel. And going from Illustrator, a graphic program, into a three-dimensional program was a huge step for her. And these wall panels are coming out beautiful, and we're going to actually use them on a new building on the UC campus. So here's a student designing a building for the campus, which is an amazing a project for her. And a lot of students, they've never built something real or something that works. They might have done decorative stuff, but giving them, they're part of these teams that build large working projects. This is kind of blurry, but the students sometimes think they can push the button and the machine's going to do all the work. So this is a piece coming off a CNC router. It's a chair, I believe, an interactive chair, and it's going on. They have to actually use a chisel to release it there's a couple little tabs that are holding it in place. More tools. Oh, wait. I like that one. This is a conductive tattoo. It's a temporary tattoo. Don't worry. I see some parents in there shaking their head. It's a temporary tattoo, but it's conductive. And there's actually LEDs embedded in that, and that responds to different sensor inputs. It's a researcher doing some amazing work with tattoos and how you could print electronics on your body. They're decorative, and they have functionality. I like this picture up here because it's found objects in the lab, and they put motion detectors on there, and this is actually a musical instrument that you can play, electronic musical instrument. And this is another musician building, chair prototypes, more mess. It's an amazing place to work, and I get to work. UC Berkeley attracts some of the best students, so I'm very lucky to work with all these brilliant minds. They have some of the best professors there, so I get that. Like I said, I have like the best job in the world. First day we have the students draw pictures of each other and whoever's sitting across them, and we don't expect them to be. Well, thank goodness I'm not up here. We don't expect them to be artists or anything, but as they're doing this, they start laughing, at themselves, and they're laughing. And then we have them switch and then draw another person, and the room is full of laughter. And we're like, okay, what were we just doing? We were playing. We were having fun. Now, when we start the assignment, approach it the same way. We're going to be playing. We're going to be having fun. There's some technical things you have to learn, but this is a place for exploration. And if you approach it that you're going to be playing and finding out things, learning things, there's nothing you have to know. There's nothing you have to do. It's what you want to do. What do you want to create? So today, with technology, you're given the tools that anyone can make anything they want. You just have to learn or go to the experts and find out, and then you can create that. And that's amazingly empowering. You don't have to be satisfied with anything. You can change your own environment. You can change the objects around you. You can change how you interact with those objects. Plus, you can change how everyone else in the world interacts, which is amazing. So we live in an amazing time. Thanks to the technology and how we can use it. So, and that's it. Thank you.